Hello students, welcome once again to Akshar IIT online classes. I am your chemistry faculty S. Mohan. Students, in the last class we were discussing about the atomic structure, and under atomic structure what we are discussing about the atomic number, mass number, these topics we are discussing, right? So this is the atomic structure. Okay. Under atomic structure, what we are discussing? We are discussing about atomic number, mass number, and isotopes, isobars, isotones. These all we are discussing, right? So last class we completed up to isotopes, isobars, and isotones, right? So once again in brief. Okay. So number of neutrons is equal to A minus Z. This already we discussed in the last topic. Okay, right. Now. And normally atom represented in this form, I already told you that this is Z and this is A. Here X represents the symbol of element and Z represents the atomic number, A represents the mass number, right? For example, if you take the carbon, C612 we represent. So here C represents what? Carbon. 12 represents what? Mass number. 6 represents what? Atomic number. And by using this, we can also write the number of protons, electrons, and neutrons. So, number of protons, 6. Number of electrons, 6. Number of neutrons, atomic mass means mass number minus atomic number. So, that is 12 minus 6. So, that is 6. This all we discussed, right? And along with what we discussed, we also discussed about the isotopes, isobars, and isotones. So, isotope, bar and isotone, right students? This we discuss. Isotopes means what? In which Z remains the same. Elements of same elements, atomic number remains same. Okay, same atomic number, but different mass numbers. Different mass numbers are called isotopes. And isobars, what I said, exactly opposite to them. So here in this what we can say, different same mass number but different atomic number. This we discuss. What are the number of neutrons? Atomic number different, mass number also different, both are different. Okay, so same isoelectronic species. Iso means what I told already in the previous class, isobars, isotones. Iso means what? Same. And electronic, electrons. And species means what? Atoms or ions. So atoms or ions which have same number of electrons are called isoelectronic species. For example, see students here, you know that hydrogen atomic number is 1. Atomic number 1 means what? It has 1 proton and 1 electron. So it has 1 electron, right? Now for example, if you take the helium, atomic number is 2. Means what? It has 2 electrons. And lithium, the atomic number is 3. So it have 3 electrons, right? Now what are isoelectronic species means? So I am giving the example. So isoelectronic species example are hydrogen means H minus and H minus and He and Li plus. Now can you say what is the H minus and He Li plus? Can you say what is the meaning of H minus? This is hydrogen. This is H minus. What is H minus? When an atom becomes negatively charged, this already we discussed in the previous classes. Very good. So when an atom takes electron or electrons, it becomes negatively charged. When atom gives electron or electrons, it becomes positively charged. Yes, this already we discussed. Okay. So here, this hydrogen has only 1 electron. See here, 1 electron. If this hydrogen takes 1 electron extra, already it is there, 1 electron is there. But now if it takes 1 electron, now hydrogen, electron is coming, electron is negatively charged particle. So it's taking 1 electron. So now we can represent this as a H minus. Right? When H minus means what? Here 1 electron is extra. But already atomic number is 1. Means what? Already 1 electron is there. This is 1 electron plus it's taking 1 more electron. So total number of electrons, how many? 2 electrons it became. Yes or no? Now, Helium, let us see. Helium atom number 2, 2 electrons. Okay, here also 2 electrons are there. Right? Now come to the lithium. Lithium atomic number is what? 3. 3 electrons are there. But I have written an Li plus. Li plus means positively charged. How the atom becomes positively charged? By giving one or more electrons, by losing one or more electrons. Okay. If it is losing 1 electron, it will have 1 plus. If it is losing 2 electrons, it will have 2 plus. If it is losing 3 electrons, it will have 3 plus, right? But here 1 plus is there. The meaning is what here? Lithium is losing. See a minus. Here I get plus, here gaining, here it is losing. So 1 electron. Okay. Then it becomes what? Li plus. So here a total number of our electrons are how many in the lithium? 3. But now it is losing 1 electron. So now number of electrons present in Li plus is how many? 2 electrons. So see here now, all here are 2 electrons. Okay. So this is H minus, this is He helium, this is lithium. So hydrogen negative ion, helium, and lithium positive and lithium ion. Okay. So now all these three having same number of electrons. Clear? So these species are called, species means what? Atoms or ions, which are having same number of electrons, isoelectronic, same number of electrons, are called isoelectronic species. Very simple. Is this clear to you? Any doubt? No? Once you check for 1 minute, try to understand. Okay? Now let us see the next topic is what? Isosters here. Isosters also similar, same number of electrons, and here it is in a compound. It is about a compound or molecule. Here we have taken only atoms you have taken. So here you see only one single atom. But here if you see a molecule means what? A group of atoms, right? Molecule is what? A group of atoms. So here in this molecule, in the group of atoms, if the same number of electrons are there, then that is called a isosters. Okay. Okay. Now here you see example is given like carbon dioxide and dinitrogen oxide. So carbon dioxide and dinitrogen oxide like this. Okay, N2O. Now here let's see how many electrons are there in this one. So here one carbon. So carbon, you know that atomic number is 6. So 6 electrons are there. And oxygen 2 are there. 2 oxygens are there. Each oxygen atomic number is what? 8. So each has 8 electrons. So 8 twos, right? So total number of electrons 6 plus 2 8s are 16. So 6 plus 12 is 16 is equal to how much? 22. So now in this carbon dioxide, total number of electrons are 22. Clear? So this is a molecule. Molecule means made up of atoms, not this individual atom. It's molecule. It's made up of atoms. So this is a carbon dioxide molecule. And now in this total number of electrons are 22. Yes or no? Now you count, try to count here. How many nitrogens are there here? 2 nitrogens. 2 into, what is the number of atomic number of nitrogen? Very good, 7. So how many electrons are present? 7 only. Atomic number represents number of electrons, right? So write 7. Okay, plus your oxygen is there. What is the atomic number of oxygen? 8. Very good. So 8 electrons. Now 2 7s are 2 into 7 is how much? 14 plus 8. 14 plus 8 is equal to how much? 22. So see here now, 22 electrons, 22 electrons. So this both the compounds having same number of electrons. Clear? So in which the number of the molecules in which the number of atoms and number of electrons are same, then that is called, they are called isosters. Okay. Now you find the, I'll give the, now you find second one. Second one, for example, I'll give to you HCl and F2. HCl and F2. Come on, check how many electrons are there in HCl and how many electrons are there in F2. Come on, students, try fast. Hydrogen, what's the atomic number? 1. So how many electrons? 1 only. Plus chlorine, what's the atomic number of chlorine? 17. How many electrons? 17. Now total number of electrons, how many? 1 plus 17? 18. So total number of electrons are 18. So now let's come to the fluorine. How many fluorines are there? F2. 2 fluorines. Fluorine atomic number. Come on, count fast. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Which element is the fluorine? Ninth element. Very good. So ninth element. So atomic number 9. Number of electrons also 9. Now 9 twos are how much? 18. So total number of electrons how many? 18. Here how many? 18. So the meaning is what? Both are having same number of electrons, that is 18 electrons. So what they are called? Isosters. Clear to you? Any doubts? So one more. This last and purely you have to do. So calcium oxide. No, I'll take okay. Calcium oxide and magnesium sulfide. Calcium oxide plus and magnesium sulfide. Come on. Count students fast. Find the number of electrons in both the cases. Finished. How many? Calcium atomic number 20 plus oxygen is 8. So 20 plus 8, 28, right? Magnesium is 12 plus sulfur is 16, 28. So both are having 28 electrons. Clear? Okay. So with this, we completed this synopsis. Okay. So now we do the practice sheet. Open the page number 33. Now let's see the practice sheet. Open the page number 33, everyone. Take the pencil. If you have a notebook, you can take the notebook also. So see now, practice sheet, concept based questions. Rutherford model is also known as planetary model, apple pie model, plum pudding model, watermelon model. What is the right answer? Planetary model. Rutherford model is called planetary, and Thomson model is called what? Plum pudding, watermelon. Okay, so that is the Thomson's model, right? Next, alpha particle is denoted by alpha particle. Alpha ray scattering experiment I discussed. Yes, helium nucleus. Very good. So that is third option. He plus 2. Next, the size of the nucleus in the order of. This also we discussed. The size of the nucleus is 1/1,00,000th part of the size of the atom, and atom size is 10 to the power of -8 centimeters. Angstrom units I told you. So 10 to the power of 1/1,00,000th part. Okay. So 10 to the power of -8 into 10 to the power of -5. Bases are equal. Power should be added. -8 -5 -13. So the answer is 10 to the power of -13 is the right answer. According to electromagnetic theory, if electron revolves around the positively charged nucleus, yeah, this already discussed in the Rutherford model. When electrons revolve around the nucleus, then what happens? According to electromagnetic theory, the electrons loses their energy. So answer is first option. And next is what? Atomic number is denoted by. Just now I told you that atomic number is denoted by Z. Next, mass number is denoted by. Mass number is denoted by A. Right. Isoelectronic pair with 32 electrons. Just now we discussed about isoelectronic. Isoelectron means same number of electrons should be there. So you have to check, students, that one. Boron atomic number is 5, so 5 electrons. Oxygen, 3 oxygens are there. Oxygen 3 8s are 24. 24 plus 5, 29. But there is given -3 also. Let's do. One by one we check. Here what? BO3 -3. Second one is given what? CO3 -2. Boron. Boron atomic number is 5, right? Hydrogen, helium, lithium, beryllium, boron. Boron is 5. So write 5. Plus, how many oxygens are there? 3 oxygens. 3 into oxygen atomic number is 8. Yes or no? Every time you count like this, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, like this. So it will get repeated for you. Plus here -3 is there, means what? 3 electrons are added. When minus means what? Electrons are added, right? So now 5 plus 3 8s are 24 plus 3. 5 plus 24, 29 plus 3, 32. Yeah. So 32, they are asking 32 only. Okay, in this species 32 is there. Now let's check whether here also 32 are there or not. Now carbon, what's the carbon atomic number? Hydrogen, helium, lithium, beryllium, boron, carbon, 6. So 6 plus, here again 3 oxygens are there. 3 into oxygen, oxygen is 8. Again minus 2 is there, means what you have to add the electrons 2. So 6 is 6 plus 3 8s are 24 plus 2. Okay, 6 plus 24, 30 plus 2, 32. Yeah. So in both the cases we got 32, and the question is asked that the isoelectronic pair of 32 electrons. So the answer is A option. Right. Now 8th one, which of the following is a Moseley's relation, that is direct formula. So 2 is the right option. Underline, take that one. Number of neutrons can be calculated by using the formula. Come on students, you have to say number of neutrons can be calculated by using the formula. Just I have written. See here, number of neutrons can be calculated by using the formula is what? N is equal to A minus Z. So the answer is what? First option. Okay. The neutral atom with atomic number greater than 1. The neutral atom with atomic number greater than 1 consists of, yeah, this also I told you that in the periodic table, means total we have 118 elements. In that 118 elements, only the hydrogen is the only element in which there is no neutron. Okay, except the hydrogen, remaining all atoms have the electrons, protons, neutrons, all are there, right? So here atomic number 1 means what? Hydrogen. So hydrogen consists of only electron, proton, no neutron. But they are asking that whose greater than atomic number is greater than 1. Means what? Helium and remaining all. So remaining all consist of electrons, protons and neutrons. So the answer is 4. 4 is the right option. Okay, take that. Next question here. Continue. J means Thomson's atomic model is also known as. Just now in the first question only we discussed. Okay, when I discuss the concept based question, first question, their Rutherford model is called a planetary model, and Thomson model is called what? Watermelon or plum pudding model, right? So the answer is what? Second and third. So option is 4, both 2 and 3. Now see the second question. Rutherford model of atom proved the presence of dash and it is known as dash. So here Rutherford model discovered what? Nucleus. I said nucleus. All there is are passing state except at the center. That's called nucleus. So nucleus, and it is known as what? Nuclear model or planetary model. So the answer is 2. Second option. Alright. Then come to the third question. Rutherford could not explain what? So defects of Rutherford model. This we discussed. Rutherford model could not explain the stability of an atom, and it could not explain the atomic spectra. So here stability of an atom, spectrum. So both 1 and 2 you write. Next, Moseley's name is connected with the discovery of atomic number. Okay, the direct question. Mass number of atom represents the number of mass number. See, a mass number is denoted by A. Represent what? Z plus N. Z means what? Atomic number, or protons plus neutrons. P plus N. P stands for protons and N plus N stands for neutrons. So the answer is protons and neutrons. Next, atomic number. Atomic number is what? Atomic number means what? Number of protons, which is also equal to number of electrons. So what is the answer here? 1 and 3. Number of protons and number of electrons. Next, the atomic weight of an element is 23. So here you see atomic weight of an element is given as 23. So A is equal to 23. Next, atomic number is given as 11. So Z is given as 11. Here I told you. Okay, the same question has come here. So now they are asking how many protons, electrons, neutrons. Protons, electrons, neutrons. So protons are what? Protons are nothing but an atomic number. So Z is 11. So protons is 11. Right? How many protons will be there? Same number of electrons. So the number of electrons also 11. But I want neutrons now. Number of neutrons formula is what? A minus Z. A minus Z. A is what there? 23. Z is what? 11. 23 minus 11? 12. So the answer is 11, 11, 12. Is this option is there? Yes, first option only. 11, 11, 12. Right, students? Okay. Then come to the next one. Rutherford model of atom accounts for the Rutherford model of atom, scattering of alpha ray scattering experiment, presence of electron orbits, stability of an atom, line spectra. The first one, scattering of alpha particles. So option is 1. Right? According to the classical theory, just now we discussed, Rutherford atom, according to classical laws of physics, Rutherford's atom is unstable. Okay? Because the revolving electron loses its energy and it comes closer to the nucleus and finally it falls in the nucleus. When it falls in the nucleus, then atom should collapse, but atoms are stable. The meaning is what? It could not explain the stability of an atom. So, according to classical laws of physics, here Rutherford's atomic theory is unstable. Right. Next, Rutherford experiments on scattering alpha particles show the first time that the atom has nucleus. Their top, same page, second question we discussed that, nucleus. Next, the proton and neutrons are collectively called as, nucleons. This also we discussed in the last class. These are called what? Nucleons. They are called nucleons. Next, if W is the atomic weight, N is the atomic number, then the element, then which is the correct answer? Number of neutrons is equal to A minus Z. So, number of neutrons, second. So, second is the right answer. Correct? Yes. Now, come to the page number 35. Page number 14th question. Difference in chlorine Cl35 and Cl37. Okay. So, what is given here? Difference in between chlorine 1735. Yeah, chlorine 1737 is given and they are asking what is the difference. Okay. Atomic number means what? Number of protons. Number of protons, electrons and neutrons. For first one, let's see here. So, number of protons 17, electrons also 17, neutrons 35 minus 17. So, that is 18, right? Now, this one you come. So, atomic number 17 means 17 protons. Number of protons equal to number of electrons 17. But 37 minus 17, 20 here. So, protons is same, electrons is same. But where is the difference? Neutrons. The answer is number of neutrons is the right option, right? Next, Rutherford scattering experiment is related to the size of nucleus. Okay. The alpha particle has a number of protons and electrons. Alpha particle only 2 protons, 2 neutrons. There are no electrons. So, protons are 2, electrons are 0. So, the answer is 2, 0. Now, J means level 2. The alpha particle experiment, scattering experiment shows what? Center of the nucleus. So, the atom has a very small positively charged core at the center. That is the right answer. Isobars, already discussed, same mass number. Different elements having same mass number. 3 is the answer. And 19th question. Carbon C12 and carbon C13, which is the following, is a false statement, not a true statement, false statement. So, here you see a atomic number same, mass number different, means what? Isobars. In the isobars, neutrons are different. But here it is given both have same number of neutrons. So, that option is wrong. Right, students? Next, 20th one, see here the number of neutrons in the di-positive zinc ion. See here, very important this one. The number of neutrons in di-positive zinc ion. Zinc is Zn. Di-positive means what? It lost 2 electrons. So, zinc atomic number is 30. So, di-positive means what? Zn2 plus. Means what? It will have only 28 electrons. Remember that, 28 electrons. Now, they are asking that the number of neutrons in the di-positive ion whose mass number is 65. So, now number of electrons are 28. Okay. But atomic number is what? 30. So Z is equal to 30. And mass number A is equal to 65 is given in the bracket. Now they are asking to number of neutrons. Neutrons is equal to A minus Z. So that is 65 minus 30. So the answer is 35. So the number of neutrons are 35 neutrons. So answer is 35. Did you understand here? Zinc atomic number is what? 30. And mass number is what? 65. Atomic number represented with what? Z. Z is equal to 30. Mass number represented with A. A is equal to 65. Number of neutrons is what? A minus Z. A is 65 minus Z is 30. So answer is 35. Next, the number of neutrons present in the deuterium isotope. Deuterium, yeah, this also explained you. Okay, hydrogen exists in three forms. One is H11, hydrogen H12, hydrogen H13. So this is called protium, and this is called deuterium, and this is called tritium. Okay, so here if you see the electrons, protons and neutrons in three, so protons, electrons, neutrons. So here proton 1, electron 1, neutron 0. Proton 1, electron 1, neutron 1. Electron 1, proton 1, neutron 2. Yes or no? Okay. So this is now what the question he asked, the number of neutrons present in the deuterium. Deuterium isotope number of neutrons is only 1. The answer is 1, student. Last one now, how many neutrons are present in H11? H11, how many neutrons are there? So where is the neutron? So neutron, 0. How can you say? Because this is atomic number, this is mass number. Number of neutrons is equal to what? A minus Z. So this is A is 1, Z is 1. 1 minus 1, 0. Clear? Very good. So students, with this we completed the third synopsis, and one more worksheet is there for you. Okay, practice my task time. So it's a very simple and very easy, and the next class we are going to discuss about the fourth synopsis. Clear to you? So students, you practice after this chapter, the first chapter, that is after completing atomic structure. I am going to conduct one small test to you, right? So every day you prepare, you'll have a test by end of this month almost. Okay, and that's all. Yes students, any more doubts? Are you reading? Are you practicing? Read and practice. These are very, very important concepts. So these are not there in your textbook. What I am teaching, this is what we are teaching, this is higher standard. Okay, this all will be very, very, very helpful to you when you are going to crack JEE Mains. Clear? So that's what, practice. Right. So with this we stop today. Bye, and take care of yourself.